Hello team, welcome to my session on Coffee with Prab, and today we're going to discuss about some of the foundation topics on network security. It is part of my new series which is called Network Security Foundation Masterclass. Agenda of introducing these videos is to give you the context of the network security topics completely from scratch, talking about networks, type of network, OSI, protocols, and these topics not only useful for the network security team, it can be useful for the GRC team, it can be useful for the people who are preparing for a certification, any certification which can be CompTIA, IC2, ISACA. My name is Prab, and without wasting a time, let's start with the first part. Thank you so much. Okay, so let's get started with the module 1, which is called networking groundwork. Before we jump into the core topics, let's first understand what is computer network. Computer network is a two or more device linked together so they can exchange data, whether it with the help of wireless or with the help of wire. Let's take an example. We have a system A. Okay, it has a C drive, it has a D drive, it has a E drive. And then we have a computer B. Okay, now computer B want to access the data from A. So he need a media. Now this media can be my wired media, or this media can be my wireless media. So we have a mechanism by which we can able to move data from A to B. So when they are working together through this media, this representation is called as a computer network. So today what you see, the network is completely different before 1970. So computer network, that's why I said two or more devices linked together so they can exchange the data. And those devices might be the PCs, it can be server, it can be phone, it can be sensors, it can be cloud instance. And the link can be a wired, which is a copper cable or fiber, or it is a Wi-Fi, which is called as a Wi-Fi, cellular, microwave, or satellite, which we're going to discuss in the further slides. Now, it was not like that what you see today computer networks. Okay, so if you take an example of the computer network perspective, in 1969, earlier the computer used sneak net. Okay, so what is sneak net is, it refer to a practice of transferring data between computers by physically moving a storage medias. We used to have a floppy drives. Rather than using a network connections or internet connection, we use a floppy disk, we use tape drives, and we move data physically from one location to the other location. And that actually wasted a lot of time and also have a risk of data loss, and it stopped the real-time collaborations. And networks basically solve those pain points by letting device share with the help of link. And that's something we need to discuss now. So we have a different type of computer networks. Okay, so first is called as a PAN, personal area network. Let me give an example. This is your phone 1 and this is your smartphone 2. We're using a Bluetooth. I'm sure in your phone you have a Bluetooth option, and through the Bluetooth you exchanging a file. Before we use WhatsApp, so today we use WhatsApp, right, to exchange the messages and image, but it was not like that before 2015 or 2012. So we used to enable the Bluetooth connection both side. We used to create a peer-to-peer connection, and through that we basically exchange the images, files from one mobile device to other device. And the distance is very less, and that group of device which is communicating by Bluetooth and exchange the data, that kind of a network is called as a personal area network. Okay, then we have a LAN. LAN is what? So we have an office. Within the office we have a switch, we're going to discuss in the further slide, and we have a systems which is connected within that switch. So system A can only communicate within that systems of the networks, and it cannot able to communicate outside the organization. So that network is called as a LAN. It is same like when you go to the hotel, so you dial the extension number, right? You have an extension to call reception. You have an extension to call the peer room members, but you cannot do the calls from that landline to your friend's phone number or your home. So they give you extension numbers. You can call them. It is free. So same like we create a network within the office. We have a group of systems which communicate within that office, and that is basically called as a LAN, local area networks, which can be one building or campus. We need a high-speed internal sharing. We can use Ethernet and all that. Then we have a Wi-Fi. The same within the organization, instead of computers are connecting via wire, they connected over the wireless. The Wi-Fi that you use at home, right? So you are sharing the access point with your family member. If any guest come, he want to connect the Wi-Fi, definitely you will not the person who going to give him a cable. This is the cable connect and access. Then no. You give them a password, and by that you can able to connect with the Wi-Fi, and that is basically called as a wireless LAN. It means we have one access point and all systems within the house can able to connect with the access point. But if someone is sitting 100 kilometers from the house, can he able to connect? No. So the access point will only work which is basically cover a particular frequency. If in that house the access point cover that frequency range, any device in that particular radar can able to connect with that, and all will basically get a same LAN network IP, and they can able to communicate together. But if we have another apartment and they have an access point and they want to communicate, they cannot able to, because they are in different network. So this is basically one apartment, they have access point. This is a one apartment, they have access point. Whatever the computer part of that network, they can able to communicate within that, but they cannot able to communicate with these systems because they might configure on a different IP with different network. Then another network we called as a CAN, corporate area network. So let's say example, we have a building 1 and we have a building 2. Okay, so they already have a one LAN. All systems are communicating with that. We have a dedicated LAN and all systems are basically communicate with it. Now what you need, you want this building to communicate with this building and this building to communicate with this building. So they want all these buildings to communicate with each other. And that is basically called as a campus area network, where the several buildings in one location can connect. We can consolidate multiple LAN and we can have a university campus with the fiber rings and all that. So summary is that mobile to mobile, peer-to-peer connectivity is a PAN, distance is less. Then within the office, you're communicating with any system within the office, that is a LAN. Same you're doing over the Wi-Fi, which is called LAN. And within the one building, you're communicating, that is basically, or between the two different buildings within the same locations. You have a multiple branch within the same locations and communicating, that is basically called as a CAN. So next topic is called as a metropolitan area network. Now metropolitan area network is called the net. So what we discuss is, let's say example, this is Dubai. This is Dubai. Okay. Now in Dubai, we have an office here 1, and within a Dubai we have another office, and here we have an office. It's not in Abu Dhabi. Within a Dubai, okay, we have a 3 office. Is it clear? We connecting that office. Okay, within the Dubai we have a 3 office. We connecting that. That is basically called as a metropolitan area network, which connects site without long haul circuits. Or second use case is in Dubai we have a CCTV cameras. Within Dubai, not Abu Dhabi or other part of the city. Within Dubai, we have a CCTV cameras and all are basically connecting with the one panel. And through that panel, I can able to see the entire visibility about the city. So all these cameras are connected with one network. That is basically called as a MAN. Now what happened is, we're taking a same use case. Now in this use case, what happened is we have a second is called as a WAN, a country or globe. Now we have a UAE. Now you have a one branch in Dubai. You have one branch in Abu Dhabi. You have one branch in Ras Al Khaimah, and you have one branch in Sharjah. All are basically want to connect together to share the data and all that. And that is basically called as a WAN, wide area network. So with the help of internet connection, they can able to use that. But now they have an office in India. They have an office in Africa. So you are working with Emirates Airline and you want to track the flights which is going across the multiple cities or multiple countries. So for that, we need to have one network which is called as a GAN. Now, you might be thinking, Prab, WAN and GAN look like a same. See, WAN is a network connecting office or branch across the geographic region or country. Okay. But on the other side, when I say GAN, okay, when I say GAN is a global scale network connecting. and they're using a satellite or global internet infrastructure. Okay, like as I said, we have a Emirates airline system. They link the offices, airports, airplanes across all the countries. Is it clear? So they can able to track their Emirates flights. Okay, that something is there. So thin line difference is that the WAN like a national courier which deliver the package across cities within your country, and GAN is like an international courier service that ship package globally connecting to the whole world. And the last is basically called as a, like you seen the right now this the Tesla CEO, right? Okay, so he providing a satellite internet connections which you can use in the flights also. How they providing that? With the help of satellite. So when you travel across the globe and all that through the satellite, you can get access of internet from anywhere. Okay, so that is basically a live example of that. Now next is basically called as a SAN, storage area network. So storage network is like, it's not a network. It's like we have a multiple storages. Here we have a storages, and each storage has a IP, and through that particular IP you can able to access storage. So that is basically called as a storage area network, which is used for data center rows, high speed block storage transfers and all that. Okay, so same like we have a computer with IP, same like we install a storage which store the files and everything. It is configured with the IP, and through that particular IP you can access the storage from anywhere. Okay, so it is just configured like a computer IP. It has their own channel, and through that channel you basically access those storages. You access through the IPs, and that is called as a SAN. Okay, so next topic, in the computer network, we have a two-way of transmitting data. So we have a two type of signals. We called as a nature of signal. One is called as analog. Okay, one is called as analog, and one is called as a digital. So we have a two type of signal, and the signals can be traveled by two type of media, wired media and wireless media. Let me repeat again. When computer A sending a data to B, there's a two way to send the data. There's a two type of signals we have. We have a two type of nature of signals we have. One is called analog, and one is basically called as a digital. Okay, so first let's understand the analog. Analog is more like a continuous. Okay, it is smooth. Okay, so that is called as analog. So your old AM FM radios, you hear continuous signal through airwaves, right? So that is basically called as an analog. Analog mean continuous signal. Now how to understand that? Let me explain you. So if you take example, this is basically called as analog. It is same like you're talking directly to someone face to face, and your voice flows smoothly and continuously, not broken up into the pieces. Is it clear? So question is, where you find your analogs? Your traditional radios, which is your AM and FM, are basically using the analog. Your old fashioned telephone calls, landlines, this is the landline you have, this is the phone you have, there's a cable is there. So data which is transferred through this cable is direct end to end. Okay, so that is basically called as an analog. But problem is that your computer understands digital. So digital mean information is turned into a separate pieces. So in this section, if you can see, let me show you that. So let's take example. We have a system A and we have a system B. So data is divided into ones and zeros. So it is not sending a continuous. Okay, it turn the data into separate piece, which is called ones and zero, and it is precise and organized. It is same like when you're sending hi on WhatsApp, right? H then hi. So each letter you type is distinct and separate, not flowing continuously. So your computer and smartphones, your streaming videos, your internet calls, all are the perfect example of the digital. So in more layman term, analog is just like your clock with hands smoothly moving around. It never jump from 1 second to other. And digital is like a digital clock, changing numbers clearly and distinctly every second. Now question is, Prab, if analog digital, what is the role of wireless? See, wireless is not about analog digital. It describes how the signal need to be traveled. Is it clear? So wireless is like a road, which talk about how the signal basically move. And vehicles are the analog and digital. So analog use continuous wave, where varies, which is about amplitude frequencies. used in broadcast, radio, TV, and digital transmission send pulses that represent bits 0, 1, 0. And today it is used in Ethernet, DSL and all that. So if you see the traditional landline, so we have a landline, the cable comes. Okay, so the cable is connected with your landline phone. But when you remove that cable, you use the modem, remember? And then from modem, there is one cable is going to the computer. So converting the analog to digital. This is the role of a modem. Okay, so modem is a device which work on the physical layer of OSI model, which convert your analog to digital. Understood? That is why traditionally what happened, if you want to use internet, the phone will not work. And if you're using a phone, internet will not work. Today, we have a shared connection. Okay, so today your telephone line, whatever is coming is basically analog only. And modem is a device which convert analog to digital. Okay, so analog is listening to your traditional radio, and digital wireless is watching like Netflix via Wi-Fi at home. That something is there. Now next topic is basically called as a networking devices. Okay, because definitely computers connected via media and media connected by the devices by which we transfer the data. So we have a different type of devices. We have a hub, we have a switch, we have a router, we have a modem, and we have a firewall. And each and every topic we're going to discuss in detail. Okay, so first we're going to discuss about the repeater. Now what is repeater? Repeater is like a device which is used to amplify the signal. Let me explain you. We have a system A and we have a system B. Now let's say example, this is a cable. You're sending a data from A to B. Now signal is like that, but here what happens, signal is basically dip. So what we did, we installed the repeater which is used to amplify the signal. Now repeater is two type, wired and wireless. And the best example of wireless is the Wi-Fi that you use in the house. Let's say example, there is a ISP line is coming to your house. This is your house. Okay, now you have a first floor, you have a second floor, and you have a third floor. The modem is installed on the first floor, ground floor. That Wi-Fi signal cannot go on a second floor. So in the second floor, we install the wireless extender. So what it does, it extend this device signal to other network, other locations. Is it clear? Because the Wi-Fi that you use in the house, okay, it can basically cover a particular frequency range. Or let's say example, you have only one floor and you install the modem here. So the wireless frequency can work till this part, but I want a wireless signal here also. So here we install the extender which extend his signal to there also. So that is the example of wireless repeater. Same like we have wired repeater we install on the cables to extend the signals. So ultimate goal of repeater is to amplify the signals. Next is basically called as a hub. Hub is a device. Hub is a word mean a group of ship. You know ship? Ship. Group of ship. Hub is like that only. Hub is called as a non-intelligent device. We don't use today. So let's say example, this is my hub. We have a system A, we have a system B, we have a system C, and we have a system D. So we have a system A, we have a system B, we have a system C, and we have a system D. If so hub is a device which is used to connect all the systems which is connected with the same port. Now if A want to send data to C, A send data to hub. What hub does it, hub broadcasts the data to all the ports. Even the data is not, the D doesn't want the data, he will receive also the data. So if someone initiate the sniffing tools and all that, he can able to intercept the other data also. Now just imagine if A sending the data, B also sending a data, C also sending data, they're broadcasting the data to all the ports. So what happened? It create a collusion. And that lead to the data loss. What is collusion? From here also data is coming, from here also data is sending. So there is a possibility of accident, and accident lead to the data loss. So hub is a device used to connect multiple systems together on a same network. But one problem is that it broadcasts data to all the ports. Even it gives the data to the desired system, which is not authorized for that. Is it clear? Modem we already covered. So whatever the connection is coming to our house, let's say example of India, we have a Reliance, we have a MTNL, we have a BSNL, we have a Airtel. They are basically sending me a telephone line. This telephone line basically carry the analog, but your computer or laptop understand digital. So we install the device which is called as a modem. So modem is a device which convert analog to digital and digital data convert to analog. So it is just act like a multiplexer. It is act like a translator who convert the analog to digital and digital to analog. Let's move to the other device, and all are basically work on the physical layer of the OSI model. Okay, so next point is called as next device is called as a NIC, network interface card. Now it is, see, you have a laptop. Okay, in that laptop you can see this section, a card by which the media is connect with the switch, a media connect with the hub, or media connect with the router. So the device which is installed on your motherboard, and by which your computer or laptop connect to the network, that is called as a NIC card. Nowadays in some laptops they don't have this card because your motherboard has an inbuilt wireless access point, wireless device, wireless NIC, which is used to connect with the Wi-Fi. But you can see the NIC card in your laptop, you know, this portion you can see, okay, by which you can use a cable, and by that cable you can connect with your switch or with the hub. Next is called as a bridge. The bridge is a device which is used to connect to different topology. So today, if you take example, your access point also have a feature of bridge. How? The Wi-Fi that you use in the house, okay, it has a Ethernet port, this kind of a port they have, so that a cable which is coming from a landline can connect, okay, or you can use that Ethernet port to connect with your wired switch, and then that wired switch is basically connect with the wired computers. Now we also have a Wi-Fi users. So now this Wi-Fi user sending a signal to this, from there this wired network port can send the data to this. So by this way my wired system can communicate with my wireless systems, okay, and that is a best example of using access point as a bridge. So ultimate goal of the bridge is used to link two different LAN segments. It here in this case we use Wi-Fi and wired, okay. Then the next device we called as a switch. Now switch is called as an intelligent device. Switch is actually two type. One is called as a manageable switch, manageable switch, and one is called as a unmanageable. So what is switch? So switch does the unicasting. In my next slide I'm going to cover that. So we have a system A, we have a system B, and we have a system C. So what we learned in the past, in the case of hub, if A want to send data to C, according to hub it will send to B also. But in the case of switch, if A want to send data to C only, we send the data to switch. Switch will check what is the destination MAC address, because physical address of a LAN card is called as a MAC address, and they will check in the memory table. They have a memory table which is called as a CAM table, okay, we called as a CAM table. So CAM table basically store the information about the list of MAC. So according to that CAM table, it basically send the request to the particular port only. So what is CAM? CAM stand for content addressable memory. It's a special memory used in the network switch to store and look up the MAC address quickly. So you can say like that CAM table is nothing, it is just like your contact list, okay. So your network switch used to know where to send the data. So now the use case is when A sending a data, it attached the MAC address of the C. So it sent to the port, it sent to the switch. Switch will check into CAM table that this MAC address is basically on which port, it on port number C. So it sent the data directly to the C. This is how the unicasting works. So this is how it provides the security. Is it clear? So the difference in hub and switch: hub broadcast the data, switch unicast the data. First time when you open the switch, when you start the switch, it send the broadcast request to all the ports. You see the light is bling in all the ports. Why? Because he want to learn how many systems are connected on each port, and then fetch the memory address, MAC address, and store in the CAM table. So next time when A sending data to C, according to MAC address only, it send the data. Okay, and one more important information is that the CAM table entries can expire if the device goes quiet for 5 minutes. That's why the entry in the CAM table is dynamic in nature. Is it clear? So now this is the feature I talk about, the unmanageable. But in the manageable switch, what happen is we have an option to map that, okay, we have a switch here. We have a port 1, we have a system B, we have a system C. FF is the MAC address of system A. AB is the MAC address of system B, and CC is the so MAC address is a physical address. You can't change it. Okay, it's a manufacturer address. So first time when it pick, you can make it static. So now if any new system want to connect with this port, the link will not up, because we manually map that this MAC address always connect on the port 1, on 2 and 3. This is only possible in the manageable switch. Second thing is that in a manageable switch, we have an option that, okay, we can communicate A and B only. Even all three are part of a same network, but logical segmentation, all we can create in the switch. So switch is a device which used to unicast data. Access point we already discussed. It's the same thing what we have covered. Okay. So as we're talking about switch, we have a two type of switch. One is called as a unmanaged switch, a simple switch that you can bring and configure in your house. You just need to connect the power, connect the systems and all that. Let me explain again how the switch works. So this is the switch we have. It is an unmanaged switch and it has a 4 port, 1, 2, 3 and 4. Now when you start the switch, the light is blink in all the ports. So he discovered that port 1 has one MAC address, 2 has a MAC address, 3 does not have, and 4th port has a MAC address. And that information stored in the CAM table. Now if A want to send data to D, every system has a table which is called as a ARP table. Let me show you. So here you can see this is called as a ARP table, which maintain the neighbor IP and MAC address information. Is it clear? So what happened now is, next time when A want to send data to C, which is on port B. So according to ARP table, they see what is a C MAC address and they attach source is basically A MAC address, and B from the ARP table pick and attach the MAC address. So when it's sent to the switch will check that this MAC address on which particular port, on that particular port it's in the data. We don't have any option to do the further modification. Now if system is disconnected and any other system connect with that, switch will take the new MAC address. So entries are dynamic in nature. But we have another switch which is basically called as a managed switch. So this is used in enterprise. We have option to customize. You can log in by window, you can set the settings, you can create a VLAN, you can have a port mirroring. Now what is port mirroring? So let's say example, this is my switch. So we have a system A, we have a system B, and we have a system C. As you know, if A want to send data to C, it can directly send to C. But now we have a system D and he want every copy of traffic. So it means if A sending to something B, A sending something to C, I want one copy of traffic to be received by D. So this port is mirror with other ports. This is called port mirroring. So now if A sending to C, one copy of traffic go to this port. All these options have an option to customize. In this case, we also have option that, okay, this FF is the MAC address of A. It always link with port 1. 9B is the MAC address of C, which is linked with C. So now if D system connecting to this port, the port will not be up, because manually in the switch we configure these features. That is not a feature available in the unmanaged. That is a feature which is available in the managed switch. So that kind of a functionality we get here. Now next topic in this module we called as a media. Media is a mechanism by which we send the data, and we have a two type of media: wired media and wireless media. So under the wired media, we have a coaxial cable, twisted pair cable, fiber optic cable. It means there is a wire. So we have a system A and we have a system B. So there is a dedicated wire through which we transfer the data. So whether it's analog and digital. But wireless is basically not using a wire. We're using a wireless frequency by which we send the data. So data is more intercept in the case of wireless, because we don't know who intercepting. See, if anyone coming with the cable and connecting, I can see that. But in the Wi-Fi, okay, anyone can able to intercept the data. So data communication become biggest concern in the case of wireless. And in this module, we're going to discuss about the different type of media in details. So first, let's get started with the wired media. Okay, and the wired media, the first point we're going to discuss about is this one called as a coaxial cable. Do you remember like your old when you're talking to TV? Okay, and TV channels will run. The backbone of the cable from which the channel your TV you running, or the cable what you see, the channels what you see, it is basically using a coaxial cable. So coaxial cable actually used in your cable TV network. So now if you can see this picture, this part is actually the one which carry the frequency and carry the data. This is called as an inner conductor. Then this is basically called as a dielectrical insulator. Okay, which maintaining a space. Then we have a outer conductor, a braid or foil serve as a ground shield. And then this is basically called as a PVC jackets. So coaxial cable is, so if the question talking about which is the most strongest, the answer is coaxial cable. It is difficult to break and all that. It's a very, very strong cable. But problem is that it generating lot of current attenuation, which lead to the data loss. So one of your traditional computer network, the cable that we use was the coaxial cable. Your TV network, when they broadcasting a channels to all the TVs, they using the coaxial cable only, the black cable that you can see in the house. Okay, so that something is there. Now here what happen is the signal propagate as electromagnetic waves between the inner conductor and shield prevent the external EMI. What is EMI? Electromagnetic interference, which can lead to the data loss. But yes, we have a higher chance of data loss in a coaxial cable because of current in nature. Second is basically called as a twisted pair cable. Twisted pair cable are structure and signal. We have a 2 and we have a 4 twisted pair cables, copper conductors. The twisted pair cables are providing a better functionality in terms of data loss, less data loss compared to the coaxial cable. And it offer two type of twisted pair cable, shield and unshield. Now here you can see this is called as a shield, and they are twisted. Why they are twisted? Because of the cable attenuation. Okay, so because of data, so data attenuation. What is data attenuation? This is called data attenuation. Attenuation mean the loss of data. So, you know, remember when you want to protect yourself from your dad. Now let's say example, dad is coming with the belt. So you try to twist your body so that the impact should be less. Same like here, the cables are twisted together, so we have a less data loss. So this twisted is basically used to reduce the EMI and reduce the attenuation, which lead to the reduce of data loss. But we have a two type of cable, shield, twisted, and there is a called as a shield. There's an extra shield is there which provide the extra protection. So which one is more expensive shield? Which one is difficult to install shield? Which one is difficult to bend a shield? Which one is cost effective? Which is called as a unshield twisted pair cable. Okay, so next is basically called as a fiber optic cable. We discuss about twisted pair, we discuss about coaxial cable. Now we're going to discuss about fiber optic. So if you talk about a cable which provide you the highest speed of data sending parameter, or the cable which is more immune to any EMI or data attenuations, the answer is basically fiber optic cable, because it uses light as a frequency to exchange the data. And you know, light is considered as one of the fastest frequency to send the data. So today, if you see nowadays, Jio, Airtel in India, they're using a fiber optic cable, and because of the reason, the speed is basically high. So what has happened here is we have a system A and we have a system B. Now they have a fiber optic cable under which we have a glass tube. The light frequency goes through that particular tube. But problem is that if someone tried to tap this cable, the frequency is gone. That is why we say if you want to send sensitive data and you don't, and you are very confirm about if someone tried to tap the cable, the signal is lost, you're okay with that, then you will use fiber optic cable, because in fiber optic cable, it immune to any kind of EMI, it immune to data attenuation and provide the highest speed of the data transfer. Now fiber optic cable is two types, single mode and multi-mode. Single mode, we are having a single frequencies by which we send the data. Multi-mode, we are using a multi-frequency by which we send the data. Multi-mode basically carrying the, nowadays multi-mode is basically used to carry the data. So they basically transmit the electrical signal into light signals, and receiver convert the light back to electrical signals, and it is immune to EMI and offers extremely highly bandwidth functions. So far what we covered was more like a wired concept, and now we are going for the wireless. Now one more important thing you need to understand here is, in wired fiber optic cable single mode we use in a campus, data center trunks and all that. In multi-mode we are using metro, long haul carriers and all that. So that something is basically part of the wired. Now we're going to discuss about the wireless. So far we discussed about 3 type of wire. Now we're going to discuss about the wireless, and the first, which is a very common use everywhere, is radio wave. It occupies the lower frequency and the spectrum. Now what is spectrum here? It's a very good thing. What is spectrum? Spectrum refer to the range of electromagnetic frequencies over which signal can travel. I repeat again, spectrum is referred to the range. It is basically called as a range over which signal can travel. So think of it like a giant musical keyboard where each key is a different frequency. And just like a notes, different frequency behave differently and carry different tune of data. So when you're talking about radio wave, it offers 2 type of frequencies. One is called as a lower frequency, and one is basically called as a higher frequency. It is only for knowledge. Lower frequency mean longer wavelength, and higher frequency is basically called as a shorter wavelength. So when I say longer frequency, okay, it basically bend around all the obstacles and travel farther but carry less data. But on the case of higher frequencies, it pack more data but need a clear path and don't reach as far. So if you're looking for the bigger distance and all that, we go for the longer frequencies. And if you're looking for the higher frequency, it can carry short data. So now question is basically where we use this. You know, today the Wi-Fi that you use, the Bluetooth that you use, they all are example of the radio wave. That's why when you're connecting a Bluetooth headphones and all that, you move around your house and all that, different walls are there, right? From one distance to other distance, you can able to listen to the songs over the Bluetooth connection without any interruptions. That is the best example we have. Second thing is that there is one statement we are using is 3 kHz to the few gigahertz. Now what is the meaning of that? Let me explain. So what happened is, as I said, spectrums are the range of electromagnetic frequencies over which signal can travel. So lower frequency bend around the obstacles, and higher frequency pack more data because we have a bigger frequencies, parameter frequency. Now question is, what is the frequency units? Okay, so you need to understand one thing. Spectrum is really like a long invisible highway, and this highway used to send all sort of wireless signals like your phone calls, Wi-Fi, and even signal from satellites. So if we take an example of the lower frequencies, is it clear? So it is just like the slow steady truck. I repeat, slow steady trucks, the trucks that you can see on the highway, right? So we have a big and slow trucks on the highway. They can go a really long way and even go around the obstacles like building, hills without much trouble. On the other side, we have a higher frequencies, which is a shorter videos, which pack more data. So these are like a sleek, fast sports cars, and they can carry massive amount of data very quickly, but they need a clear open road. So when we're talking about these frequencies, the frequencies are measured in a hertz, which is called a cycle per second. And to handle the huge range in the frequency, we have a 3 type of hertz. One is called kilohertz, 1000 hertz. One is called megahertz, and when we have a gigahertz. So these are basically called as a frequency range. Hope it is clear now. Now we